Hi there and welcome back to Triplicate and the mood lights. Had intended to do 2, maybe 3 videos through the year on this, pick at it, away at it a bit, get it a bit better, but of course hadn't got around to it, and now we are almost in December and I've decided to drag it out again and try and do some work on it. Basically we have 2 jobs to do. One, we really want to try and get these sensors, the PIR, the light sensor and the microphone, affecting it somehow, and the inside of the globe is painted with silver paint at the minute. I tried to get a semi-silvered finish and it all just ran and sort of pulled up and didn't stick to the glass very well. So it is. So I want to move on with that. So to that end I bought a can of frosted glass, which presumably should stick to glass and provide a frosted finish. Which should just diffuse our LEDs enough, hopefully, to make it look nice. I also bought another globe of that size in plastic, and I was going to try maybe sanding that to produce a frosted finish to diffuse the LEDs, but I can't find it. I've no idea what I've done with it, and it's basically it's in 2 halves and they're nested together, so it's like half of this size, so it can't be that hard to lose, but I've lost it, so I shall hopefully find it and we can move on with that. Now, to see what effect these are having, I've decided, just as it is, it's just going to be too hard to debug. We need to find out what these are doing. Now, to test them, I just got it doing something with some LEDs in test mode. But I have decided to rig up a debug interface for it, featuring an FTDI board, which that is one, and just some wires that I can unscrew the base and just put a connector out and put this to this and a USB to it and just print out what's happening so I can debug it easier. So I think that is probably our first task. Okay, so we have added a little debug output, which is simply an FTDI serial to USB board wired onto a UART port on the STM32, and for now, if we look at this, I've just got a test print which every second goes round and just prints out the current tick time, and I'm using HAL UART transmit, which will hang up for the whole time it's printing the string out, but that'll only be a few milliseconds, so we're going to go with it for now, and if it starts hanging up the code, we'll have to use, I don't know, the interrupt or something, but for now we're just going to live with it. So if we fire that up, okay, yeah, so it's actually doing something. So the other end, it's just similar to the one I use for the GPS. To read the GPS, it simply runs a
a timer, and every time it gets the timer it looks to see if there's any serial input, and if there is it prints it out. So let's do this. So here we go, and if we hit run, okay, yes, you can see it's printing out the time in milliseconds every second or so. And yeah, you can see the little light blinking here to tell it's getting comms from here. So that's working nicely. So now we need to figure out what we want to print out to tell us what's going on in here and coming out of our, let me see that, our input sensors. Okay, so let us first have a look at our PIR sensor, our motion sensor. So if we set this running, and you can see here I've just got a little panel which will light up. There we go. You see me moving. There we go. That's the actual PIR sensor, and it's got some sort of a timer to stop it going off. And anyway, that's what's coming out of it. Right, should we now look at our light level sensor? Okay, here we have our light level. That's the bar graph showing the value coming out, and that's the value in numbers. So let's fire the old thing up here. So that's saying 400 odd, and that's the light level. And the little bar graph is not showing at all because 60,000 is the maximum. And it's pointing into the room, and it's a sunny day. Admittedly, it's sunny January day in the north of England, which is never that light. But if can you see what I'm doing here? Yeah, if I spin that so it's more pointing at the window, we get up to the thousands. And if I put it straight up, we get a few more thousand. And if I take the magnifier lamp here and shine it straight in, we get 60,000. So that's working in, but I'm not sure it's sensitive enough, because it will be pointing into the room horizontally like that. Maybe I should have done it so it's on the top. Perhaps I need to look in the electronics and see if I can, I think it's just a bias resistor, get some more sensitivity out of it. Or we could use some kind of a log converter to get a logarithmic value, so we get more sensitivity at darker levels. So shall we try that for a start off? Okay, now we have this lower bar graph, which is the logarithmic one, which is actually a lot better. So if I put my hand over it, it will go down to nothing. So, and that is actually pointing, that's not too bad, that's pointing into the room. If I pull it so it's pointing actually directly away from the window, it's not bad. Oh. And again, if we shine the light straight into it, we can go up to the top. Okay, so I think that's the way to go. We might actually try it with that before we start getting the soldering iron out and modifying the circuitry here. Okay, shall we move on and take a look at sound? Okay, let's move on to sound. So, same thing, we've got our sound sensing. It just senses the level of the sound, doesn't do anything clever. And that is sending values to here every 100 milliseconds. So if we fire her up, there we go. and you can hear it detecting me moving about when I talk. And here's our little microphone, and if I go and talk near to the microphone it pretty much overloads, does it? No, it doesn't. I think it's got a automatic gain module circuit in it, but that's alright. We can do something with that. So let's now try adding our logarithmic conversion as well, and see if that produces results nearer what we want. Okay, here we are. I think let's try and go for quiet. I'll sit here as quiet as I can. Alright, we're getting 500 or 600 on our little number, just from like the whirring of the laptop fan and so forth. So we just want to drop that bottom value down a bit, I think, which I will do. Let's try 200. What was it, 400 or 500? Well, we'll see what that does. Still quite high on the logarithmic on the 0. We need to be, again, silence. Silence! 500, there is a bit of noise there as well. Okay, let's fire it up and see what we get for silence. Oh, something gone funny here. Okay, I'll see what the matter is. Okay, fixed my bug, so we'll fire it up. Yeah, and as you can see with me talking loudly and pointing at the microphone, we're getting pretty near. And if I shut up, as I'm sure you've all been wanting me to do, yeah, then it just comes on range if I whisper. So that's good. So now we have like a continuous value for the light and the sound. Shall we try and make a continuous value for the PIR? Okay, well, I'll have a look into that and bring you back. Okay, so what we have here is another, what's actually a Windows progress bar, but it's what I'm using to display levels. And if we hit run and I start moving about, yep, you can see every time the PIR sensor sends a new trigger, it bumps it up an amount. And if I keep moving, come on, it'll bump it up to the top. And if I sit still, it'll gradually decay down to the bottom. So we've got some outputs from our 3 sensors, so 3 continuous outputs of sorts. So what are we going to do with them? Okay, a question of is it worth it, but done quite a lot of work on this debug stuff, as you can see. Okay, I have it so I can test individually the PIR, the light sensor and the microphone, and then all of them, and the individual ones. Get this back. If they're individual, I get the raw, the log and the out. But if it's all of them, I just get the out values. I've also instituted these sliders which allow me to actually set a value, so I'm not, if I just want to test them out, something's behaviour when the microphone's activated. I can just pretend it's making a sound rather than having to try and shout into the microphone nonsense to get it to go. So I have here the PIR, so okay, there we are. You can see the PIR is working and we went through that, but now I have, if I grab this, it then actually listens to this, and there's a bit of a delay, but it's only test stuff, so we don't care. So that's the PIR. Let's just look at the light level and then the sound level quickly. Right, go. So we go back into our thing here. Yeah, you can see there's the raw light level, here's the log, and the out, which is just the scaled log more, so we can see the number. And if I were to put my finger over it, see it goes down to nothing, and just let a little bit of light in. Come on. See the log comes up quite quickly to that, which is room light. It's pointing up at the ceiling light. So if I'll put that over there so the LEDs don't blind the camera. If I point it straight into the room, you see it's getting a nice range of values. And if I put the magnifier light on, that overloads it. Okay, so now let's try the microphone. Okay, so now we've got the sound level. Let's see if it's quiet. Yeah, we're still getting a bit of ambient noise from the room, and if I tap on this, that'll overload it all. So that's nice, that's working, and it's fallen off again. And again, if I do this, it just allows me to set a level, but normally that's just so I can test the signal conditioning for the light and the sound and the PIR. Let me shut that off, go into this, but normally I would just have all three outputs shown. Okay, so we just get the three outputs. As you can see, if I move, come on, PIR goes up. If I turn the light on, the magnifier light on, the light goes up. Stick my hand in front, the light will go down. And if I'm talking here, you can see the output from the microphone. And if I shut up, yeah, that's good. And these will all work nicely. Okay, so we're ready to go. We're actually ready to work on our effects and how these, our moods, and how these are going to affect them. Okay, so first up, let's have a look at our random mood. So the sound will affect the speed the colours change, and the movement and the PIR will affect the direction of travel, which is either long or short, so it's like a switch over at a certain point. So let us fire that up and see how it looks. Okay, so I've jammed it so it stays on the random one all the time, and if I talk in here, you can see it's changing around quickly. Okay, so let's go into our debugging app. So let's first switch the PIR to low and the sound to low, and you can see that it's slowly changing between colours. Very nice. So let's switch the PIR, the sound to high, and it's after a little delay it's the switches to fast, so that's something we want to fix. And we switch the PIR to high and it appears to be faster, but it's just going through more colours between the different endpoints. Not explaining this well. Okay, so we have a little problem there which we need to fix. So if we go into mood random, the problem is if it is on a long change between colours, it gets to the end of the change and says, oh, what colour shall I go to now? Before it checks the time, the speed, it's going to the next colour. So that leads to a delay when you change suddenly from slow to fast, and if it's silent and you suddenly talk into the microphone, that will happen. So what I've done here, just checked to see if the current time is greater than the timeout time, and reduce the current time to suit. Just time val is the time, so it should now, if I change from low volume to high volume, it should immediately start going quickly. So let's see how that works. Okay, so you can see it is now, when I speak suddenly, it does start going fast suddenly, which is nice, and we will just confirm that on here. So that's slow, and that is fast, and suddenly it goes fast. Fast. Alright. So we saw it briefly working using the PIR and the microphone. Let's try that again. So I need to go into here, reset it and run it again. So suddenly talk loudly, that works very well. But I would like it to slow down a bit slower. You see what I mean? Go back to it. If you stop talking, to more slowly go back to the quiet mode. So I shall have a look at that. Alright, so the way it works is it rectifies the sound and takes that as a peak. This rectified value is a peak, and then it decays the peak simply linearly by subtracting a decay value from the output. So this microphone decay value was a constant and is now a variable, so that's all I've done. So let's see how that works on our random. Okay, so here we are. So if I were to, sorry, this will do for the sound level on the recording, go like that. Well, it's fast. Okay, you can see it seem to stick at maximum value for some while, then decay the top half quite slowly and the bottom half quite quickly. So I think the sound level output conversion is not as we would wish, but I think on the other hand the random mood is now working as we want it. Okay, so what we have, or had originally, so we have our microphone signal coming in, and then we have essentially a rectifier which gives us that, and then we have a decay which actually produces a linear decay, not an exponential one, which is probably part of the problem. So we have that kind of thing, and then at the end we put our log, our log curve. So what we have coming out is it goes up, sits at the top of one, and then drops, and of course goes up. And so what I have done is, so we have our rectified microphone signal, so I haven't done this in parallel, it's just avoid drawing that bit twice. So we've disconnected it there. We have our log converter. So this gets hard to draw. We have what just looks like a compressed signal, and then we have our decay. So again, it just looks compressed compared to this. It's hard to draw. I could spend some more time doing graphics, but I'm not going to. So anyway, that's what I've done. I've just flipped the decay and the log round, and oh boy, that took me a long time, just to do with scaling things in integers, the usual problem, and then getting confused with signed integers and unsigned integers and trying to bodge old code up instead of going through it and making sure it worked properly. Anyway, shall we see how that works? Okay, here we are. So let's have a look on here, see how we're doing. So it's the bottom one is the one we really want to see, and as you can see, that seems to be alright. So if I clap, it goes up to maximum, and if I'm quiet, you'll see it drop down nice and gently to minimum. I'll clap again and then be silent. And you can see also that the lights speed up, and when I shut up, slow down nice and gradually, and then obviously speed up again because I'm talking again. So I am happy with that. So I started this video in the end of November, and it's now the end of January, so I am going to call it for this. Didn't get on as far as I'd wanted to, as ever, and I kind of decided I'm going to try and put a bit of effort in and finish this to where I think I'm going to go with it, and then maybe have a complete rethink as to how it works. So probably another 2 videos coming soon, but for now I'm going to finish up on this, and we are going to have a look at something else because quite frankly I'm getting a bit sick of it. So for this video, that is it. So it's goodbye for now from Triplicate. Goodbye.